In this module, we will be discussing solving word problems by doing algebra. There are basically four different types of problems we will be solving. First, number or logic problems. Second, figure problems, also known as geometry problems. Third, mixture problems. And fourth, distance problems. In this first short video, I am going to discuss the first type, which is solving number or logic problems. Regardless of the type of problem you are working on solving, it is important to always start off by identifying what you need to find out and assigning X to that. I call that the labeling part. In some problems, there is only one unknown, while in others there may be several unknowns. Even if there is more than one unknown, you will need to assign X to the first unknown and then figure out any of the other unknowns by relating them to X. For instance, one number problem might be the sum of two consecutive even numbers is 58. Find the numbers. To solve this, there are two things you don't know, the first even number and the second even number. So for my labeling part, I might say at the very beginning that X is equal to the first even number. If X is equal to the first even number, the second even number must be X plus 2, because to get from one even number to the next even number, you always have to add 2. In the problem, it says that the sum of the two numbers is 58. So, here's my equation, X plus, in parentheses, X plus 2 equals 58. Now I really don't need to put in the parentheses around the X plus 2. I just did that just to show you that you do have two separate numbers. Then I would go through and solve that particular equation. And you see that I went through and did that. I have an answer of X is equal to 28. Remember, in the problem it said to find the numbers. So I do need to give a complete answer and check it. If X is equal to 28, I can come back to the labeling part, this part right here, the X plus 2, being the second even number. If X is equal to the first number, 28, I just need to add 2 to that and I get 30 for the second number. And then I can always check. And certainly if I add together 28 plus 30, I do get 58. So I do have a correct answer. Here is an example of another number problem. Rather than me just doing the problem, I'm going to be asking you to do the problem in stages and to pause the video at times to try it yourself. I am thinking of three numbers. The second number is twice as large as the first number. The third number is 5 less than the first number. The sum of all the numbers is 31. What are the numbers? As I said earlier, it is important to start off your problems by doing the labeling part. So I would like you to pause this video and write down which of the three numbers in the problem you would let X equal, and what the other two numbers in the video would also be in terms of X. When you're done, please start up the video again. Okay, hopefully you have had time to go through and figure out the labeling part of the problem in the way that you would do it. Here's the way that I would do it. I would let X equal the first number. The reason I would do that is because they tell me in the problem that the second number is twice as large as the first number, and the third number is 5 less than the first number. So if that's true and X is equal to the first number, I would have 2X is equal to the second number, and that third number is X subtract 5. Then you can see, once again, I have my equation written. It says that the sum of all the numbers is 31. And then I would just go through and solve this. The first thing I would do is I would get rid of the parentheses, and then I would go through and add my x's, and you can see that I'm doing that. 4x minus 5 is equal to 31. If I added 5 to both sides, I would get 4x is equal to 36, and then dividing both sides by 4, I would get x is equal to 9. Once again, I would put this information back into the labeling part. I know that the first number, X, is 9. That must mean that the second number is 18, which must mean that the third number is equal to 4. if I add up all those numbers, I would certainly get 31 for my answer, so the problem does work. A logic problem is really very similar to a number problem. It's just more real life. Here's an example. You bought a hammer, a pair of pliers, and a wrench. The total cost was $60. If the wrench cost 3/4 as much as the pliers, and the hammer cost twice as much as the pliers, what was the cost of each item? Once again, the first step is to identify what you want X to equal. I would probably let X equal the cost of the pliers, since the other two items are compared to its cost in the problem. So you can see here is my labeling part of the problem. From that then, I have an equation, and the equation would be x plus 3/4 x plus 2x is equal to 60. Now this is one of those problems in which I have a fraction, and it can certainly be solved many different ways. Because it has the denominator of 4 in that fraction, I would probably multiply both sides by 4, and you can see that I have done that in the second step of the equation in order to simplify that just a little bit more. And you can see that I went through and did that and get a final answer of x is equal to 16. Once again though, you do need to make sure that you give the cost of each item. So if the cost of the pliers is $16, the wrench would be 3/4 of that, or $12. The hammer would be 2 times as much as the pliers, which is $32. All three items would total $60. So the answers are correct. Here's another logic problem that I'm going to ask you to do first by yourself. Just like the last time, I'd like you to pause the video while doing the problem, and then start the video again to see how I might do it. Tom spent a total of 4 hours doing homework. He spent twice as much on math as he did on social studies. He spent 30 minutes more time on reading than on social studies. How much time did he spend studying each subject? So go ahead and do your labeling part. Pause this please, and then turn this back on again to see how I might go through it. Once again, you can see my labeling part on this problem. I would let x equal the time spent on social studies, because both the math times and the reading times in the problem are compared to social studies times. So I would let x equal the time spent on social studies. It says that he spent twice as much time on math, so I would have that equal to 2x. And he spent 40 minutes more time on reading than on social studies, so I would have that equal to x plus 40. You can see my equation written there, x plus 2x plus in parentheses x plus 40 equals 240. Remember, because I'm talking about minutes in this problem up here, that 40 minutes, I need to keep everything in the same denomination. So I changed 4 hours to 240 minutes. Then, as I go through and solve this, I would get 4x plus 40 is equal to 240. I would subtract 40 from both sides and get 4x is equal to 200. So now x is equal to 50. So that means that he spent 50 minutes on social studies, 100 minutes on math, and 90 minutes on reading. Once again, adding all those up, I do have 240 minutes. So that is the answer to this particular problem. As I said at the beginning of this video, there are 4 different types of problems that you need to become familiar with in this module. Before viewing the next video, you might want to practice several more of these types of problems, and can find them in this module. As always, I'm available through email or chat if you have questions.